Okay, welcome to section 4.6. Tonight's lesson is a really important one. I know all of your Algebra 2 teachers are going to want you to have this skill down. We have a pretty big warm-up to do right here. So go ahead and get out your graph paper. You can see pre-work up there. It's written in baby blue, so you know you have something to do. Go ahead and write the term pre-work down at the top of your graph paper. And here's what I'm going to ask you to do. I'm going to ask you to take both of these equations, y equals negative 2x plus 5 and y equals x minus 6. For each one, I want you to create a coordinate plane, create a t-chart, and then fill out that t-chart on your own, plot those points, and use it to graph the line for each equation. And then once you're done with that, I want you to answer the questions, what is the slope? So look at your graph and determine what the slope is using rise over run. And then what is the y-intercept? You should be able to look at your graph and tell that. And this is going to take me a little while to do, so I think we should probably end up working in concert. So if you want to work a little bit ahead of me, feel free to do that. But I'm not going to ask you to pause here. You can kind of work on your own, and I'm going to kind of work on my own. And we'll see if we arrive at the same answer. So go ahead and start setting up your coordinate planes. You'll see I'm just making a quick x-axis and y-axis. Feel free to tune me out if you wish. I will not take offense whatsoever. It's probably like a 3 or 4 minute warm-up anyway, so you can put on some headphones, listen to some music if you want. Maybe talk a little bit about what we're going to be doing tonight. We've learned to graph lines a couple different ways now. The old reliable, old-fashioned way is to make t-charts, and you come up with some input values that are appropriate and then plug them in to get some output values. This is a good skill. It will always work. Problem is it takes time. Okay, it's a lengthy process. So there are a couple different ways to graph more quickly. And one of those ways was the intercept method that we went over a couple lessons ago, where you found an x-intercept and a y-intercept. So plugging in 0 for x to find a y-intercept, and plugging in 0 for y to find an x-intercept. So 2 points make a line. You can get a quick graph that way. And it's a very easy method. Problem is most people don't use it because they kind of don't remember that it's available. Once you see what we're going to do tonight, this is the one you're probably going to go with the most, which is fine. You can always use whichever method you choose. Okay, so these are my input values. They don't necessarily have to be your input values, but I'm going to go ahead and begin on the graph on the left. So let's see, I plug in negative 2. It's going to spit out a 9. Plug in a negative 1. It's going to spit out a 7. 5. 1 is going to spit out a 3. And 2 is going to spit out a 1. And I'm just plotting my points. Like I said, if you're ahead of me right now, no big deal. But hopefully, once we connect our dots and all that kind of stuff, our lines should match up. So 8 minus 6 is 2, 7 minus 6 is 1, 6 minus 6 is 0, 5 minus 6 is negative 1, 4 minus 6 is negative 2. So I just need to plot those. 1, 2, 3, 4, 5, 6, 7, 8, comma 2, 7, comma 1, 6, comma 0, 5, comma negative 1, 4, comma negative 2. So those are the points I come up with. And then if I'm ahead of you, feel free to pause me at any point in time, because you should be coming up with this on your own. Okay, so if you're not here, pause and do it on your own to get caught up. But I'm going to assume that we have both graphs now. So you'll notice in the first, y equals negative 2x plus 5, our graph is going down the roller coaster, and it's pretty steep. So when I go to answer the slope question, I should come up with a slope number that represents that. And remember, to find slope, we're going to use rise over run. Okay, so I'm going to choose this point here at the bottom and begin rising up. So it looks like I go up 2 when I do that. Okay, and my run is 1. I'm moving 1 over. But you really have to pay attention to direction here. So if I'm going to write this as rise over run, going up 2 is considered to be a positive 2. But going to the left 1, left is a negative direction, just like on the number line. We consider that 1 a negative 1. So once again, going up 2 is positive 2, but going left 1 is negative 1. And positive 2 over negative 1 makes a negative 2. So our slope is a negative 2, and this is the type of number I expected. It's negative, meaning it's going down the roller coaster, and 2 implies steep. All right, what is the y-intercept? Well, for that, I don't have to do any math. I just look at the graph right here where the graph crosses the y-axis. So this point right here is my y-intercept. So what number is that? Well, on the y-axis, that's at 5. So it has a y-intercept of 5. Let's do the same thing over here for our second graph. Okay, what is the slope? Well, I'm going to pick a point that's kind of down toward the bottom. So I'll choose this guy right here. And it looks like I go up 1 and then over 1. Up 1, over 1. And going up 1 is a positive 1. Going over to the right is also a positive 1. Okay, so positive 1 over positive 1 is positive 1, so the slope is positive 1. And I expected a positive slope because this guy's going up the roller coaster. Let's take a look at the y-intercept. The graph crosses the y-axis right down here at this point. Okay, so my y-intercept looks like it's 1, 2, 3, 4, 5, negative 6. Okay, why did we take all of this time to do that? Well, one, using T-charts does take time. I want to emphasize that. But the main thing I want to emphasize is that a lot of this information is encoded in the equation itself. So take a look at your answers for slope and y-intercept and go back and look at the equations that they come from. What do you notice? Okay, the information was there the whole time. If I want to know the slope of the first equation, all I need to do is look right here. Okay, that negative 2 is the same as this negative 2. All right, so whatever the coefficient of that x is, if it's written in this particular form where we have y equals something times x plus or minus something, okay, we're going to call that slope-intercept form. If it's written in that format, the number in front of the x is going to tell you what the slope is. Okay, same with the y-intercept. Okay, the y-intercept right here, this 5, okay, that was also written over here. Even with the sign, it was a positive 5, so we see it as plus 5. Okay, same thing over here with the y equals x minus 6. All right, we know that the slope is 1. Now you might be thinking, well, I don't see a 1 up there. Well, it is, it's just invisible. I look for the coefficient of x, and that coefficient is a 1 indeed. Okay, so even though it's invisible, it's there, it's a 1x. The y-intercept, we came up with a negative 6 when we saw where it crossed the y-axis. That negative 6 is also sitting right here. Okay, so what does that mean? Well, if we know the slope and we know the y-intercept, we can actually graph these things much more quickly than ever having to use a t-chart. And let me just demonstrate this really quickly, and then I'm going to give you a bunch of these to practice on. So pay close attention. Let's go back and do y equals negative 2x plus 5 again. You don't need to do anything other than watch me. You've already got this on your paper. Okay, but it's as simple as, I'm going to make a y-axis. I'm going to make an x-axis. Okay, now let's use the information at our disposal. Okay, I know that the slope is -2 because that's what this guy tells me. And I know that the y-intercept is +5 because that's what that guy tells me. I'm going to use the y-intercept as my starting point. Okay, so I'm going to come up on the y-axis, 1, 2, 3, 4, 5, and anchor a point right here. This is where it all begins. Always begin with your y-intercept. That's going to give you an anchor point. Then I'm going to use my knowledge of slope. So this tells me that my slope is -2. Well, as a fraction, as a rise over run, I can consider that like -2/1. Okay, that's a way of writing -2 as a fraction. This is going to tell me where to go from my first point. If I see -2/1, I'm going to go down 2/1 because -2 tells me to go down. +1 as a run tells me to go to the right 1. So down 2/1, down 2/1. And those are going to generate my next points. I could also bring it back the other way. I could go up 2, left 1, and that would be the same as writing +2 over -1. And this is also an expression that works. Up 2, left 1. You'll see that all of those dots end up along the same line. You don't necessarily have to have the staircase when you're plotting these. I was just doing that to show you the rise over run. But if you connect all of the dots together, okay, if you connect all of the dots together, you're going to end up with the same line that we just had anyway. It just happens a lot more quickly. So once again, you're going to begin with your y-intercept and plot a point, and then you're going to use slope to figure out your next few points. And what we call this form, we call it slope-intercept form. It's known across the country as y equals mx plus b. Okay, where the m tells you your slope, and the b, whatever number is here, plus or minus or nothing, tells you your y-intercept. Okay, so see if you can use this knowledge to graph a couple of these on your own. Okay, so this is we're still in the pre-work, but this is the bulk of the lesson right here. I've given you 5 equations. All right, so you're going to have to come up with 5 separate coordinate planes on your paper. And then I want you to do a quick graph of each of these, beginning with your y-intercept. Okay, plot that point, and then use your slope to determine your next few points, and then connect your lines. So go ahead and do this for all 5. You might have to stop and think about some of them, and then we'll go over answers, and hopefully they all match up, and anything that you're not sure about will get cleared up once you unpause. So go ahead and pause now, and then we'll reconvene to go over answers. Okay, let's see how we did. I'm going to go through each of these as quickly as possible, beginning with y equals 2x minus 1. So that -1 tells me to begin right here at -1 on my y-axis. That's my y-intercept. And then I have a +2 for my slope, so I always like to think of that as 2/1. I usually write that down. So I'm going to go up 2 in the positive direction, right 1 also in the positive direction. Up 2/1. Up 2/1. I can bring it back the other way if I wish. I can go down 2/1, down 2/1, and that is what I would connect. So go ahead and compare your line for y equals 2x minus 1 with my line for y equals 2x minus 1. They should be the exact same line. Now, for some reason, they look a little bit off. I can tell you right now that my graph paper is slightly stretched horizontally. So they might be slightly different, but the main thing is they're both going up the roller coaster, they're both steep, and they cross the y-axis at -1. Let's take a look at number 2, y equals 1/2 x. Some of you might have gotten confused here because you did not notice a y-intercept. In other words, there's no, plus b value over here in y equals mx plus b. But there is, it's just kind of hidden. Okay, like literally we see nothing over here, right? Well, that's the same thing as writing something like +0. Okay, so 0 is actually our y-intercept. What does that mean? Well, that just means that we're going through the origin. So if you don't see a number, your y-intercept is 0. Okay, a negative number obviously ends up down here somewhere, and a positive number obviously ends up here somewhere, but nothing, neither negative nor positive, it's going to be right there at 0 itself. All right, our slope is 1/2. It tells us that information right there. And so when I write that as rise over run, yeah, it's the same thing. It's 1/2. So that's why I always wanted you to write a coefficient in front of the x. Like you could write this as y equals x/2, but it doesn't show the slope, right? This shows the slope. So I'm going to go up 1/2. Not up 2/1, it's up 1/2. Up 1/2. I could go down 1, left 2, down 1, left 2, and those would both work out. Okay, so hopefully you had your points in the right place. Are we going up the roller coaster or down the roller coaster? Well, we're going up, which was implied by a positive coefficient. Are we steep or gradual? We're gradual. And remember, fractions less than 1, they're going to give you gradual slopes. Okay, number 3, y equals -3x plus 2. We begin right here. That's our b value, our y-intercept, right there above the origin at +2. And then our slope is going to be -3, because that's the coefficient of x right there. So you want to use your starting value. -3 as a fraction would be like -3/1, right? So I'm going to go down 3 to the right 1. Down 3 to the right 1. Down 3 to the right 1. I could bring it back the other way, go up 3 to the left 1, and it means the same thing. Okay, so we should have a line like that. Notice it's steep and it's going down the roller coaster. That's what the -3 tells us. Notice that it crosses the y-axis at 2. That's what the +2 tells us. So this y equals mx plus b format, what we call slope-intercept form, tells us all the information. Remember, the slope is m and the y-intercept is b. We just have to make sure that we are in function form, and all of these are. You won't always be in function form. Sometimes you might have to manipulate things around. All right, number 4, y equals x plus 3. We begin at +3. That's our y-intercept. A little tricky one here. We have an invisible 1 in front of the x, so that's our slope. Okay, so think of it as 1x, and remember 1 is the same as 1/1. So I'm going to go up 1/1, up 1/1. I can go down 1, left 1, down 1, left 1 to achieve the same effect. So you should end up with something like this. This one's going up the roller coaster. I consider it neither steep nor gradual. This is the dividing line, 1x. You should have about a 45-degree angle on that slope because it's exactly in between the quadrants. All right, let's try the last one, y equals x, and this is virtually the same line. Notice I don't have a y-intercept listed. That means you can consider this to be something like plus or minus 0. It's a 0, it's nothing. Okay, so where is nothing? It's right here. It's at the origin. Now, slope of 1 just has y equals x, so the slope is 1. Remember, that's 1/1. It's the same slope as the last one. So up 1/1, up 1/1, up 1/1, up 1/1, down 1/1, down 1, left 1. And that's that 45-degree angle I was talking about. Kind of splits quadrant 1. Quadrant 1 is 90-degree angle, so it's going to split it in half. Okay, how'd you do? This is the major skill, and now we're just going to hone in on it. So instead of making t-charts, now we are going to use quick graphs using y equals mx plus b, what we call slope-intercept form. Okay, so now you already know the knowledge for the lesson. Let's just see if you can execute it. All right, so it says the linear equation y equals mx plus b is written in what we call slope-intercept form. The slope of the line is indicated by the m, or the coefficient of x, and the y-intercept is the b, whatever the plus number or minus number is beside there. Okay, so this is example 1. You also need to have this down on your graph paper. So you have a lot of graphs tonight. I'm asking you to go ahead and graph -2x plus y equals 5. And notice, is that guy in slope-intercept form? The answer is no, he is not. So you're going to have to put him in slope-intercept form first. So get y by itself, it's function form. Okay, get y by itself, and then you'll be able to tell what your slope and y-intercept are. Once you've done that, go ahead and graph this guy on your graph paper. Should not be much of an issue at this point. So good luck. Go ahead and do that one on your own, and then unpause when you're ready to go over answers. Okay, hopefully you're done. First, like I said, you needed to rewrite the equation in slope-intercept form. So let's see what that's going to look like. What I would do is, after I've copied down negative 2x plus y equals 5, you need to add 2x to both sides. If you did not do this, you're probably going to be wrong. So you always have to get y by itself first, because remember, we have to fit the format y equals mx plus b. And right now, the y is not by itself. Okay, so I have to put it in function form in order to be able to do this. All right. After I add 2x to both sides, I do have y by itself. 2x and 5 are not like terms. This is why I always wanted you to write the x stuff first and the loaner stuff later, because it fits that format y equals mx plus b. What's my y-intercept going to be? Well, it's going to be 5. What is my slope going to be? It's going to be positive 2. So if you're looking at your graph right now, it should be going up the roller coaster in kind of a steep manner, and it should be crossing the y-axis at 5. Let's watch that happen. Okay, so your graph should look something like this. A beginning point at positive 5, because that's where the y-intercept is. And then a slope of 2 means up 2 over 1, 2 over 1. So I'm going to go up 2 over 1, put a point, up 2 over 1, put a point, maybe put another point, maybe even go back the other way, and then you connect those with a straight line. So go ahead and compare your line to mine. They should match equally. All right, if you did not get that, you need to go back and figure out where you went wrong, or maybe bring questions to class. But we're going to go ahead and move forward. So here's example 2. Graph 10x plus 4y equals 12. Notice this one is also not in slope-intercept form. You're going to have to put it in slope-intercept form. So go ahead and rearrange all this stuff so that you get y equals mx plus b. And this one's a little bit more complicated. Okay, so put it in function form first. Okay, and that's going to be a two-step process. And then go ahead and graph it when you're ready, and then we'll see if our graphs match up. So go ahead and hit pause now, and then we'll reconvene to go over answers. Okay, let's go ahead and see how you did. On your paper, the first thing that should have happened is you would need to rewrite the equation. So you should have 10x plus 4y equals 12. And you're going to have to do some pre-work in terms of getting the y by itself. This is a two-step process, like I said. We'll begin by subtracting the 10x. And when you do that, you get 4y equals negative 10x plus 12. Okay, it's important to realize that you're not done. That y is not by itself. It's got a 4 in front of it. So to get y by itself, you're going to have to divide both sides by 4. And this gets that heart method thing involved. So the 4's cancel here. You're going to be left with y equals, and then be careful. You've got negative 10x divided by 4. Okay, that's going to reduce to negative 5/2 x. Just like we learned back in a previous chapter. Okay, positive 12 divided by positive 4 is positive 3. So probably the most important step is remembering how to put something in function form. And this function form in this case is also known as slope-intercept form. Y equals mx plus b, where the m tells you the slope, in this case negative 5/2, and the b tells you the y-intercept, in this case positive 3. So let's use our knowledge of both of these things to create our graph. Always begin with the y-intercept. So the y-intercept here is positive 3. So on my coordinate plane, I want to put a important point at positive 3 on the y-axis. Now I'm going to use my slope. My slope is negative 5/2. So I'm going to go down 5. 1, 2, 3, 4, 5, and over 2 to the right to put my next point. And notice that's going down the roller coaster, which I would expect with a negative slope number. 1, 2, 3, 4, 5, and then over 1, 2. And that's basically all I need to create my line. You can bring it back the other way if you want, but I'll go ahead and connect these guys. This is the graph you should have. Notice it crosses the y-axis at +3 as expected, and it's steep and going down the roller coaster, which is what -5 indicates. Okay, so if you got this one right, you have learned the major skill. If not, you need to go back and practice it on your own until you can do it by yourself. And now we're going to extend our knowledge just a little bit more with example 3. So go ahead and set up another coordinate plane. And this time you might be on your second or third piece of graph paper or on the back, and that's fine. On one coordinate plane, I want you to graph both of these guys. And if you want to do them different colors, if you have colored pencils, that would be preferable. Otherwise, you know, maybe like a dark line for one of them and a light line for the other. But go ahead and graph y equals 1/2 x plus 8 and y equals 1/2 x plus 4. And after you get both graphs on your coordinate plane, I want you to just kind of look at them and see if you can understand something kind of peculiar happens here. See if you can maybe come up with a reasoning behind it. Okay, go ahead and do those on your own, and then we'll compare graphs once you unpause. Go ahead and pause now. All right, let's take a look at how you performed. I'm going to go ahead and color code. And for y equals 1/2 x plus 8, I think I'm going to use the color green. And notice this guy starts at 8, so 1, 2, 3, 4, 5, 6, 7, 8. And your slope is 1/2. So I'm basically going to go up 1 over 2. Up 1 over 2. I can bring it back the other way if I want. Down 1, left 2. With a y-intercept right here. And then when I connect those, you know, I get something like this. So that's going to be my top line. Okay, for y equals 1/2 x plus 4, I'm going to use red. So this one is a very similar line, but it begins at +4 on the y-axis. Notice it's the same slope, so it's up 1 over 2, up 1 over 2, down 1, left 2, down 1, left 2. And when I connect, I basically get the same line, it's just shifted down. And so the difference in these guys' y-intercept is really what separates the two lines. What do you notice about those two lines? Okay, well, there's a special word for that, and you've probably already thought it. They are parallel. And the deal with parallel lines is that we can actually predict which lines are going to be parallel by looking at their equations. Notice that they do have different y-intercept. Okay, one crosses at +8, and one crosses at +4. But what do they have in common? Well, they have the exact same slope. Okay, when you have the exact same slope, you're going to move up and down this coordinate plane at the exact same rate. Okay, and so what ends up happening is basically anytime you have equations where they're written in y equals mx plus b and they share the same slope, you know that you're going to have parallel lines. Okay, so that's something to kind of keep in your toolbox for the future. Here's the last thing I want you to do, and you don't have to copy any of this down unless you want to, but I'm going to give you some pairs of equations, and I want you to look at all of these. Okay, so go ahead and write down example 4. And then of these 4 pairs of equations, I want you to choose the pair that will be parallel lines when you graph each equation. So choose the pair where the graphs will both be lines that are parallel. Okay, go ahead and think about these and make your choice. Pause if you need to, and then unpause once you have your answer, and we'll see if we match up. Okay, which one do you think it is? Well, I'm going to briefly go through each of these because you should be able to visualize them actually. If you look at A, a slope of 1/2 is going up, it's positive, but it's gradual. A slope of -2 is going down because it's negative and it's steep. So you would get something that looks like this for letter A, and those definitely are not parallel. Now, just as a little aside, they do happen to be meeting at a 90-degree angle. And the term for that, hopefully you remember from middle school, is perpendicular. So when you see slopes that are negative reciprocals of each other, in other words, you could flip one half and negate it to get a -2. Negative reciprocal slopes are going to give you perpendicular lines. That's not really our lesson today, but we will come across that again. All right, let's look at letter B. A slope of +3 on top is going to be steep and going up the roller coaster. A slope of -3 is going to be steep and going down the roller coaster. Those also intersect. They're not perpendicular, but they are steeply intersecting lines. If you look at D, a slope of 4 on the first one is super steep, and a slope of 1 for the 1x is kind of somewhere in the middle. So those also intersect, forming an x. Nothing too special there. The correct answer was C, and I feel pretty confident that you guys were able to get that. Both of these have a slope of -5, which means that they're both going down the roller coaster in a very steep fashion, and the exact same slopes will produce parallel lines. So C is the correct answer. All right, thank you for your patience. Good job with that. If you understood everything that happened during the slideshow here, you're going to be ready for your assignment. And if not, go back over the parts that maybe you were a little unsure of and bring questions to class. All right, good luck on the assignment, and I'll see you soon.